Dear viewers, welcome to the program of microprocessors for technician engineers. You know it well that civilizations have been relentlessly working to make life easier and less laborious. Ideally, one wishes everything to be done automatically for every spoken word. Electronics has played a significant role in this direction. Today, electronics has helped in providing facilities in almost every walk of life, from weather forecasting and remote sensing to satellite, information management and problem solving by general purpose computers, industrial automation and control by real-time computers, down to domestic chores like cooking, washing, and entertainment at home. Electronics is at the core. Integrated circuit technology of 70s brought out a major revolution in electronics through microprocessor. The microprocessor has inherited the important characteristics of ICs such as low cost, low power, and small size. The computer architecture, particularly its stored program feature, makes it versatile. A small and inexpensive computer can be developed where a microprocessor is the central processing unit of such a machine, along with a few input-output devices and necessary software. It is an economical and viable solution for automation and control of systems and processes. Such systems are in use in any discipline of engineering, medicine, military, aviation, industry, office, etc. So the study of microprocessor is of prime importance for designers as well as users. Microprocessors are available from the simplest 4-bit microprocessors to the very complex and versatile 64-bit microprocessors. Higher-end microprocessor from 32-bit onward are mainly used in very complex systems, but 8 and 16-bit microprocessors find extensive use in dedicated applications like common appliances, instruments, industrial control, robotics, etc. Since 8-bit microprocessor cover major area of microprocessor applications in industrial controls and instrumentation, knowledge of 8-bit microprocessor becomes necessary. Out of the whole range of 8-bit microprocessors, only a few are popular. Intel's 8085 microprocessor covers major 8-bit microprocessor application base and has thus been chosen for the study. In the study of electronics, you will appreciate that major subjects covered are communication engineering, industrial electronics, robotics, consumer electronics, computers, and instrumentation, etc. Modern communication uses microprocessor-based systems to provide various facilities like error control, data routing, and data traffic congestion control, etc., which are practically not possible to be provided otherwise. Accurate industrial controls are possible through the use of microprocessor only. Microprocessor-based compact and intelligent robots can be programmed to take certain decisions under given circumstances. Microprocessor-based systems are also used in high-quality audio and visual equipment. Microprocessors have revolutionized the computer engineering and so also the computer science. Intelligent instruments used for diagnostics are mainly based on microprocessors. These have advanced signal processing features which refine the data for presentation. All this makes a clear-cut case for the study of microprocessor before embarking on the study of various advanced applications-oriented subjects in the study of electronics. In fact, it has become a core subject of electronics. The depth and breadth of knowledge and skills required in this area will depend on the functions and roles one is expected to perform on completion of a course. A technician in the industry is confronted with the operation and maintenance of appliances, instruments, and systems based on microprocessor. He is expected to have the knowledge and skill of programming the microprocessor and checking the signals available at various points of the system. To be proficient in repair and maintenance of microprocessor-based systems, the technician has to have the knowledge of system hardware as well. An engineering graduate needs in-depth knowledge of microprocessor hardware and software for system design, integration, and implementation. With the workforce, demand comes mainly of technicians for operation and maintenance of microprocessor-based systems. Polytechnics are sources of such manpower. Faculty in the polytechnics has to be upgraded and retained for imparting knowledge in this high-tech area. In order for a polytechnic teacher to be able to produce competent and useful manpower, it is essential that the teacher himself must have sound knowledge about the basic concepts involved in the working of a microprocessor and its interfacing with other components of the system built around. And to top it, the teacher must also be able to apply this knowledge by way of not only developing application-oriented projects using microprocessors, but also be able to service and troubleshoot them. To learn about microprocessor-based systems, one has to start with minimal knowledge of microprocessor concepts and techniques. As such, microprocessor contains thousands of components, but one needs to know it from functional point of view. Microprocessor architecture tells about the basic functional capability of the microprocessor required information. This further requires the user to learn the instruction set programming. The user is normally interested in a microprocessor-based system rather than mere knowledge of the microprocessor. So knowledge about memory, input-output devices, and their integration with the microprocessor to form a complete system is required. With this knowledge, one is able to understand the working of a microprocessor-based system. Some special integrated circuit chips can help building more compact and versatile systems. The knowledge of these chips helps in understanding and integrating the microprocessor-based systems. Use of diagnostic tools helps troubleshooting microprocessor-based systems. The whole training structure of this program is shown here in the diagram. In learning the subject of microprocessors, a technician engineer has to develop two important capabilities. One is the capability of troubleshooting, and the other is the capability of system design, configuration, and integration. In order that you are able to develop these two capabilities, there is a need to develop a thorough understanding of some principles and techniques. These are diagnostic tools and techniques, programmable interfacing devices, interfacing input-output devices, memory, data converter, programming techniques, interrupts and direct memory access. Understanding of these principles and techniques will require you to develop a thorough understanding of some concepts. These concepts relate to sequential machines, computer architecture, and programmability logic, microprocessor architecture, memory and its organization, microprocessor programming, instruction set of 8085, and interrupt and DMA. All these elements of knowledge, concepts, principles, techniques, problems relating to the study of microprocessors have been organized in a total of 22 lessons. In these 22 lessons, all the learning has been focused on Intel's 8085 microprocessor. But in some applications, other microprocessors and microcontrollers are more suitable. Lessons 23 and 24 cover salient features of some contemporary microprocessors and microcontrollers. To cover higher-end applications, 16-bit microprocessors are more efficient and have therefore been dealt with in these lessons. We have developed a write-up for each of the lessons. These have been sent to you already. It is important that you go through these write-ups before and after viewing the presentation of the lessons. When you go through the write-up of each of the lessons, you will find that there are a number of exercises which are a part of these write-ups. It is advisable that you go through and work out these exercises thoroughly to develop a good understanding of the subject. We hope that you will enjoy the program of study on microprocessors and develop the essential capabilities required of electronics technician engineers in the use and application of microprocessors. We look forward to your sending us the feedback on how you felt about this program. This will help us in improving further the quality of this program. Please address your queries to Principal Technical Teachers Training Institute, Sector 26, Chandigarh.